Hello again. So this is another of our videos. This week it's kind of jumping off something I just spotted in the news that I thought was quite interesting and had quite a few parallels with general software development, which is the thing where some people have been finding that their iPhones have been telling their family they're dead. So the new iPhone, the iPhone 14, has a feature where if it thinks you've been in a car crash, it will phone the emergency services. And it's got a little delay, gives you some time to cancel the thing if you're alright. And obviously there have been some very sad stories of people who, are unable to get to their phone or something. And this feature could have actually potentially saved their lives, if not saved them a lot of sort of pain and trouble. However, the problem here is that you can't actually detect someone having been in a car crash. I suppose with good enough cameras and image recognition stuff perhaps you could, but what the iPhone's trying to do is use accelerometer data. And they're basically, in some sense, they're just taking the assumption that if you are moving at a vehicle type speed and experience a sudden change in acceleration, something has probably happened that's bad. And then they assume that if you are fine, you'll be able to cancel the message before anything happens and it'll all be fine. I mean, leaving aside the question of whether your phone should be anywhere that you could really get to within, I think it's 10 seconds, we'll come to that in a bit, while you're driving, maybe not. But what this really flags up is the problem in a lot of software circumstances where what you're trying to actually look at isn't directly observable. So instead you're forming some sort of proxy, some sort of approximation for the signal that you're seeking. In this case, you're approximating car crash by sudden acceleration change while moving at speed. Unsurprisingly, sudden acceleration change while moving at speed happens on roller coasters, happens in one case in one of these articles of someone on a motorbike who dropped their phone, and that you might consider perfectly reasonable. I mean, your phone dropping out of your pocket is probably unlikely. But what can we sort of learn about software from an issue like this? Well, the main thing here is that they've clearly embedded some sort of assumptions about the normal use and the normal environment of a phone quite deeply into this. They've assumed that the circumstance of rapid acceleration isn't normal. In most senses, that's probably reasonable, but in the case of this person in this particular article, they had a phone in a waist bag, and that was then on the roller coaster with them. In the case of the BBC telling of it, it's been referred to that if you've got your Apple Watch paired with your phone, then you might perfectly well be wearing a watch on a roller coaster, and that can send the trigger signal as well. So yeah, they've assumed that they were safe making this a proxy because it wouldn't happen normally. I would say that they've then made a slight misassumption by not reporting to the emergency services what's actually happened, but by making an assumption about what they think has happened based on the data they've gathered. Because if you read the articles, apparently the message sent to emergency services is not X person has experienced, a sudden acceleration and maybe has been in an accident. It's has been in a car crash and is not responding to your phone. In fact, it's illustrated here. The owner of this iPhone was in a severe car crash and is not responding to their phone. And that's embedding quite a lot of not very well supported data into what you're reporting. Whether or not you think in this case that's justified, it is a thing that comes up in plenty of software contexts where you think you've spotted something, so of course you go and report that. I'm trying to think of a good example of something similar, but I don't know, I saw something someone had of, they had a calorie counting app, and it was projecting that by this time next year they'd be dead of starvation, or they would weigh 0 kilos, because it had projected a recent trend and projected it far too hard, and obtained obviously an absurd result. The other thing perhaps that's being done wrong here is not so much an assumption about normal use, but an assumption about the rate of different events. So car crashes are really, thankfully, very rare, whereas dropping your phone is a common occurrence. So the extent to which you can afford to have false positive detections, is perhaps really very low, because lots and lots of things might happen that are close to being, looking suspicious, and only very rarely will it actually amount to being a serious accident. What else have you got? Well, you've got the fact that it then goes and takes an automatic action that can be cancelled, but doesn't actually allow someone to verify the action. Again, in this case, obviously it's kind of necessary. The assumption is you're unable to call for help yourself. But that's risky. It's very risky, in fact, How many of these people are then reporting that they just didn't get a chance to cancel it, they didn't know it was happening? The phone effectively, or the software, is taking responsibility, and rather than getting a confirmation. In a lot of things, you might think that you can write software to do something clever, and you might think you've written it safely enough that it can't go wrong. You really want to be very sure, otherwise, if you can't be very sure, ask for confirmation if you possibly can. So one of the other things is, while I'm pretty sure this can be disabled, disabled by a user through the menus, at least in some cases, theme parks in particular don't know how to do that. So they're suggesting here, if you've got an Apple Watch, to prevent your device from making an emergency call, turn it off or put it in airplane mode or something like that. You've got the then use of a poor workaround because somebody doesn't know how to disable your thing, or so on. And this is often comes up with software and is very risky, of basically making people work around your software, because then, well, they get used to doing things like that. They get used to clicking the button that says, yes, it's okay, do that. And that's actually one of the things that comes up over and over in computerized world risk management. We've got a book of stories of dozens of hundreds, at least hundreds of cases where computers went wrong, and in a lot of those, and in fact an entire chapter, it's this thing where you normalize people dismissing a signal, and then of course you dismiss a signal, you put your thing in airplane mode, you do something to work around the system, and sooner or later that can actually cause trouble because you've got so used to doing that. So we really a lot of software things you should take a lot of caution against normalizing doing something, but to get around the rules. So as a software solution, there's probably a few things they might have done wrong, but ultimately the problem is they're trying to do something very difficult by using this approximation data. And it's probably worth mentioning briefly that a lot of simulation stuff, software stuff, goes into two categories, and one of them has exactly those properties. So if you imagine you're doing some mathematical equations, you can write a piece of code to integrate them or project them forward in a way that you couldn't do analytically, pen and paper. And that, of course, will produce an answer that is, whatever you asked for, but probably directly. You'll move forward in time the expected temperature of a particular lake, or the expected cloud coverage at a particular location, But if you're actually solving for those quantities directly, they're direct observables in your simulations. But what you often end up doing instead is a lot more like running an experiment, but done numerically. You don't produce the observables you want, you produce some system and then you attempt to extract the observables you want. So our background, mine as well, is plasma physics. And in that stuff, you have pretty much those two kinds of simulation pretty distinctly. You can produce the equations for something like temperature of a system, and you can run those forward through transforms to work out what the temperature of a plasma system will be in future. But there's another kind of simulation where instead you basically produce a whole load of particles and you model them and you let them run, and then at some point in future you observe them and you calculate their temperature. And you're calculating their temperature is a lot like measuring their temperature in an experiment. And the point is that for the latter kind, once again, you are trying to derive some specific property you're looking for from some more general property of your system. So actually, I don't really know what the ratio is in a lot of things, but I would imagine that really quite a lot of stuff that involves simulation ends up being more like the latter than the former. You're not directly producing a statistic or a quantity, a number. You're trying to analyze a bigger picture and obtain the things that you want. So you do have to be cautious and make sure that, for instance, if what you're seeking is some rare, unusual signal, like in this iPhone case, that you're sufficiently sure that you've seen one of those signals and that you've not just seen a confounder or a less interesting signal that looks a bit like it if your proxies aren't very good. For instance, on a really, really small scale, most people know dividing by zero in software is bad. Divide by zeros are ill-formed. So what you'll tend to do if you're dividing by something that you're concerned might become zero is you'll soften that a little bit. You'll add a tiny bit to it so that it doesn't become zero. But how do you know what's a tiny bit? You need to have already characterized your signal and know that, oh, if I add 10 to the minus 15, that's always safe. That's not going to ever produce an apparent signal where there shouldn't have been one. Or that's definitely going to just produce nonsense and I'll spot that. Yeah, so a bit of a sort of almost philosophical thing this week, but I thought it was an interesting story. Fortunately, you know, it's not about anyone actually getting hurt, but it's, well, I'm sure it's not very funny for the people involved who have actually been exposed to some quite upsetting concerns about, you know, whether or not some of their relatives might have been horribly injured. So yeah, I think that's it. Unlikely events have to be very carefully handled, very carefully characterized. And, well, I'm glad I'm not part of the team that had to decide how you differentiate a car crash from someone jumping on a trampoline. So we'll be back some other time. Thanks for listening.